Hello everyone, welcome to Adafruit. This is our newest Women in Hardware interview with Anouk Wipprecht, a robotic fashion designer, and Limor Fried, of course, who is the founder and lead engineer at Adafruit. How are y'all doing?
Good. Well,
Cool.
don't forget you, Alex.
Oh yeah, and I'm Alex Glow with Hackster.io.
We're here having fun, and we're totally not robots. We've determined this right before the interview.
We have determined also that the chief problem of being a woman in tech is not having pockets to put your PCBs in.
It's so true. But we're here with Anouk,
Yeah.
and this is our interview. We're going to talk about all the cool robotics and animatronics and fashion that you do. So thank you for coming by.
Sure. Yeah.
And
So, one thing that most people know you for, if they're familiar with your work, is your spider dress, the one that has the little legs that come out, and we can show a video. And they may not be as familiar with your more recent work, and you're actually wearing an example of this right now. So what is this?
Oh, correct. Yeah, so I do a lot of couture stuff. So the Intel-Edison based robotic spider dress is very much about animatronics and like robotics. And one thing that I had was that a lot of people wanted to do like workshops, they wanted to learn, and it's really hard to teach how to make a robotic spider dress. So
Yeah.
in like less than 400 hours.
I know, right? It's like, wow, that's going to be a long course. So yeah, so I was like, since like 2 years, I've been just developing some cute things. Like these are little 3D printed ears. They're 3D printed shapeways, and basically it's a way for me to teach about like PCB design and about electronics and about like 3D printing in a more compact manner. So
Cool.
you're holding my board since I don't have pockets in my dress.
Yes.
We got these cool.
Well, this is why there's three of us.
Yeah.
Between us, we have plenty of
we
pockets.
collaborate.
So
here.
there's a couple different ones here, huh?
Yeah, correct. So these are the kitty ears that that I already created 2 years ago. I put it on Instructables. So if you guys want to make these, they're true hole boards. You can find them on Instructables. These PCBs are created at Osh Park, so you can also find them there. Take to Osh Park, which I love very much, and you guys do. Because they're purple, that's especially really cool to have purple boards. And these boards that you can see here are SMD. So these I'm gonna launch at Hackster, the Hackster platform, I hope soon. And yeah, people can also are able to make them. They're completely free. I don't get anything for it, and it's online. They're created with Autodesk Eagle, which is the PCB design software, which was formerly Eagle and now part of Autodesk. And that's a really cool way of creating your own boards, creating your own shapes, and especially what I have working with fashion, I want to have like round shaped boards, for example, and sometimes they're cornered. So yeah, making your own boards is really, really fun. It can be pretty easy. There's a lot of tutorials online, so yeah, so that's really fun.
And this is fully 3D printed. So I'm holding this, and
Yeah.
it's like how. Well, first off, how do you model this?
This is modeled in Fusion 360, Autodesk's software.
Yeah.
And first thing is defining, for example, the shape of the head. And we talked about this before. For example, like looking to see what the flexibility is here.
So nervous.
I know, this is like, I'm so scared.
Yeah, so these are printed in SLS, so selective laser sintering in nylon. And looking where, for example, the lights come through, looking what the shape can be. As you can see here, it has like a little overlay. So these are like things that you can think of like what would be important. Also the weight, you don't want them to weigh very heavily. Sort of, they're very light, sort of. Other thing is like not everybody wants to print them in SLS. For example, at Shapeways, they want to print them on their own MakerBot. So how can still the shape be defined that it can be printed either like this, or you could it here and you can merge it together, sort of. yeah. So there's like a lot of things that that you need to think of, and also like people have different shapes of heads. So as you can see here, this goes in a little bit. So for kids' heads, it's appropriate because their heads are like a little bit smaller than for big heads, and still having a correct amount of like flexibility in there, for example. So those are things that you're working with, which was for me interesting when we looked at like working for the head part, for example.
So you've got this 3D printed, and then these are PCBs that you've designed.
Yeah.
And then you order them from Oshpark, and then you do workshops where people make this, that you get the parts and they put them together?
Yeah, correct. These, the PCBs, there's 2 versions. We designed it with the Autodesk team to make it, like to see how we could go also to see where we could use Eagle. This was like 2 years ago. So together with Joshua Brook at Autodesk, I developed these boards. And then basically what it is, it's about like seeing like what kind of small components can you use. So here you can see an AT-Tiny. These are some LEDs.
I was assuming that was an AT-Tiny.
And this board is based on NeoPixels actually.
Oh, okay.
So yeah.
So 2 versions.
So then you have like a battery on this side and the controller, and then you have what looks like a switch and a photoresistor on this side.
Yeah.
But you have the wire running between them. I didn't see a way for that.
Is there like a slot?
No, I put that now here. Cool. I just glue it in. Basically, I'm working on another version that it can clip in, sort of, but now I glue them in.
Okay.
Yeah.
I want to give this back to you.
So,
I'm scared of that.
Oh, no, that's okay.
And then where do you hold these workshops, and what kind of people show up at these workshops?
Yeah, we did one at the Make Munich, which was in Germany. That was the first one. It was really fun. We had too many people, so that's always a problem.
Good problems.
Yeah, that's one of the problems. That's when too many people show up, sort of. So now we do it with write-in, sort of. So people that are signing in, they have a place or placement. Like workshops at, for example, Ars Electronica, Linz. Mostly like a lot of like makerspaces. For example, wherever I go, sometimes they ask to do a workshop at Swarovski, the head office. We did a workshop with. It was an Edelweiss, so it was like a little flower shape, for example, so same concept.
That's so Swiss.
It was really Swiss, yeah, but it was really fun. Yeah, it was a sort of we call them space Edelweiss. And for me, it's a really fun way to just work with people sort of in a short amount of time, show them electronics, show them like PCB, and show them like things of 3D printing, and that's where everything can come together, sort of.
Neat.
Cool. So speaking of Fusion 360, we were both at the Autodesk residency, which you introduced me to. Yeah. And you were working with all these different amazing machines, like the 3D printers, the super intense object ones that do like 2 materials that can be fused in different ways and support material and stuff, and also like 11-axis mills and giant like water jet cutters. What are like your favorite processes to work with? Because you also sculpt things and then scan them in 3D.
Yeah, correct.
And more of like a digital, hands-on.
Yeah, I come from like sculpting background. I did a lot of like these more intricate like geometries by hand. And in 2009, I got really ill because of the dust. It's almost like dust lungs, so breathing it in, and of course I'm using these things, but like sometimes it just like cracks in, and my lungs got really bad, and that's the time that my doctor said like, hey, maybe not do this anymore, and that would be like really devastated because I just love to work with shape. And so in 2009 I started to research what I could do with 3D printing, and I went into like 3D printing instead, like seeing how I could create these things by computer using at that time Maya, which my friend Nicolo Casas, he's an architect, introduced me into. And from that point actually my health went better, and I also found new tools to work with. Pier 9 residence program, I think is really cool to it gave us access to like a lot of cool machines to work with, other than sending it out to Shapeways, which is really handy, but you are not in one contact with your machine, sort of, and that's just give you such a power and like faster process, and you can just experiment, and especially Pier 9, they allowed us to experiment a lot, sort of, and that just made it really much fun, especially what you said, Object Connects 500. For example, that we used there, was my first time that I worked with like semi-flexible materials, other than like TPU in SLS, which is done by a company. At that time I was working with Materialize. Like again, you can walk up to the machine and you can do your tests, and as for example these kitty ears, you're looking at the stretch, what a nylon can do, how far you can bend it, and these things, and if you can do that overnight,
Or if you break one,
really
you can just have another one.
Of course, yeah, you just shoot them off, and yeah, so that's really cool for the rapid prototyping and getting it back at a big speed, sort of.
Rad.
So you have a lot of, so you started with sculpting, which I didn't know. So you did sculpting, and then you moved into 3D printing out of need. And then I've noticed that you're starting to integrate electronics, which is like totally my thing. So my question is electronics something that you were interested in, and you're like, oh, I want to combine that with sculpture, or were you doing sculpture and then you had something you wanted to do that only electronics could give you? Like how did you get these things together?
Yeah, actually I come from the fashion background, so when I was 14 years old I started with fashion design because I thought it was a cool way of storytelling. I just love what you could do, like creating an interaction with your body, with your design sort of to the outside world and that notion, but soon I found out that it was not what I wanted, because for me these fabrics that I was creating and the designs that I was creating were analog, they were not digital, they were not talking, they were not doing anything. So when I was 17, 18 I got into robotics and into electronics and like microcontrollers and processors. I think that's a good question. I was just like looking at interaction design, for example, as a field. I was looking at what my friends were doing. I got involved more with hackerspaces at that time when I was 17, 18 years old. So that's my ground and that's my base. Like just seeing what people are doing with the use of computers and programming, and then getting into electronics, and then later on finding platforms like Adafruit where you can buy these electronics and can play with them and can order them and just can freak out with them. And so I come really from this notion of like, hey, I want these designs, I want to put like a microcontroller in there, and I want to put servo motors, or like I want to make things move and breathe and light up and all of that stuff, and how to do that, you know. So when I was 17, 18, I got into another study. I quit my fashion design study and I went over to interaction design. And interaction design is really about like, okay, you have this piece of technology, like what does it do, instead of only blinking and bleeping. For example, in my case, you know, it can light up, but yeah, that's cool. But especially in the beginning of 2000, I wanted to create these things that morph, that become alive, that are sensoric, you know. And by that, through that study of interaction design and later on like getting into engineering, I could explore that notion of telling these stories, but then with animatronic garments, for example, instead of analog garments. So yeah, that's a little bit how that.
Well, you ended up being a fashion designer anyway, right? Huh? You ended up being a fashion designer in the end.
Yeah, well, I know all the basics, like especially couture. I did couture and tailoring, so I know exactly it was women's wear. A lot of people always ask me like, why don't you make things for male? And I've been trained to create women's wear sort of. But
interesting.
Yeah.
Cool. So speaking of transitioning from sort of light up things into more animatronics, you've also worked with like plasma balls and smoke machines and like chainmail and these dresses like partnered with Tesla coils. Like what other tech would you like to play with in the future? I just love experimental stuff. I always have a hard time with the boundary between like where can you put it to the body or close to the body, especially electronics in the heart, such things, and where can it be cool and explorative but safe as well, right? So that is always like the thing between that. Like smoke is a very non-invasive thing. I love to work with smoke. I have a smoke dress, so you come close, it's based on sensors, and when you come close to this dress, the more smoke is evading. So it's based on the notion of an octopus, like when it's getting scared, or the celipod, when it's getting scared, it's diving away. It's putting this cloud of ink and it's diving away. So yeah, the smoke dress is based on that notion. And so for me, smoke is a really non-invasive way, but that took a while from me being busy with a little drip system with dry ice, and it went on the dry ice and it started to smoke, which is not super maybe good for for the body, especially if you have like lamps or heat or such things. So what is a different way? So looking from that into a smoke machine, which is huge, you know, it's not sexy. So what can be a nice in between?
Like a big fog machine.
It just be like huge bustle.
Yeah. So it needs to be elegant, right? Not that you have this and you like, oh, that looks cute, but you turn around. It's
It's also like that's a constraint that you worked on. I mean, the dress is bulbous and it has a very octopus-like look. I mean, it works together. I mean, I agree. Like sometimes it is frustrating. It's like you want a thing, but it's like gigantic or it's loud. But then part of the engineering and design process is like I have this material. How do I work around the materials constraints?
Correct. Yeah, and how? Yeah. So what I did was I started out with big smoke machines, and then I went smaller and smaller, and now I have like a little system which is on the back side in a 3D printed part, so almost like a little backpack, and it's based on also a heating nozzle and silicon a silicon fluid which is pushing it through. So it's a more elegant way, and it's still doing its thing. So sometimes I like to also prototype. Even you do this big thing on the body, which is then non-sexy, but it's doing its work. And then you start to see how can the electronics become smaller, how can the mechanism become smaller, or whatever you're working with. And then you start to see that it's like trickling down and becoming this more elegant shape, sort of, and then you can start to design again. So it's all about, and that's what I love about working with more of these things, really, where art collides with technology, with interaction design, with fashion, and also like having this social element of like communication, sort of, you know. So there's so many things that I like to explore with. So to answer your question, you were asking about like what do you still want to do? One thing is like I've been busy with what you said with plasma. Creating a full dress out of plasma, but again, like putting like high electricity on the body is not super. But yeah, that's something that I still would like to do. Having like a non-translucent. I was busy with making a glass dress, for example.
Wow.
And then pushing the plasma through that. Yeah.
Whoa.
Yeah. So this more octopusy feeling.
You've kind of done that with fluids before, right? You were doing some of that.
Fluids, yeah. It becomes really heavy then. Yeah. So that's the problem with fluids.
Plasma.
Then it's sexy, but really, it's less elegant by walking with it, I guess. But yeah.
What I think is interesting, and this is like one side of what you do that I'm really curious about, is a lot of these bigger projects that you do, like the smoke dress or the spider dress or other projects, is you do them in partnership with other companies. Yeah. How does that work? Do they come to you and say like, hey, Anouk, like we really need like a spider dress that looks really cute, or do they basically give you a lot of freedom? Like, I know it's different with every company, but can you give an example of like one collaboration that you did with a company and how that worked out? Yeah,
it's always different. Mostly the companies have either a thing they work towards, so it's a product, it's a show, it's a showcase, or it's a piece of technology that they want to have beta tested. And the way that I beta test it by making stuff, and then I give them a feedback report. So often, like when I work with microcontrollers and platforms, for example, they give me the microcontroller or a set of restrictions, like, okay, use this or that, but mostly not. Mostly it's a carte blanche. They give me a microcontroller and I say like, okay, it's, for example, now I'm busy with particle. They say like, okay, we have this new generation coming out, it's a mesh-based, so mesh networking. And I'm like, okay, that's cool, because I'm always working for one dress. Maybe I want to do more things or more entities around this notion.
Like the gloves don't have to be wired to the dress, it just have to be...
Yeah, and also the connectivity, because like instead of connecting to internet, it's like creating the gateway to it, you know, and basically then you go into a conversation like, oh, that's cool, and just seeing where it really makes sense of the things that I'm doing, where I can put it in. So for example, like Intel came with the Intel-Edison, RealSense as well, RealSense I worked on, Intel-Edison, and it's basically like, hey Anouk, you're a cool maker, you know, you create cool stuff, and we have this platform, right? How can you do something with this, or how can we invite you in and you create something with this? And I say like, okay, I created a few dresses for them and with them, and then also saying like, I had a spider dress and I want to update it because I needed more, for example, especially for all these motors to work fast and to react fast. You know, I would like to. I had a black spider dress before, and creating an albino spider dress with you using the Intel-Edison and also using respiration as an extra sensor and coupling some more sensors to it. So that became the spider dress that we showcased at CES, and that became a little bit like iconic for the maker scene because of all the animatronics. Basically, the dress, when you walk into the personal space, it has proximity sensors, so ultrasonic rangefinders. And when you stand in front of this dress, it's attacking, and not just like one time attacking. It has like something that I call 12 states of behavior. So depending on how you walk into the personal space of the dress and where you're standing, it's reacting differently. So more aggressive, less aggressive. Sometimes when you're standing too far away, it puts its legs on the air and it says na 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 na. You know, as if it almost wants you to.
It doesn't actually play an audio file, does it? But that's up to the wearer.
That would be great, though.
The wearer has to provide that.
But these kind of complex behaviors you couldn't do before, maybe because you had a simpler microcontroller. When you see the Edison, you're like, okay, this is a very powerful machine.
So you're thinking like, what could be? Correct. Yeah, because the other thing is my designs, mostly if I develop them, what I said with the smoke dress, being from a system with dry ice and a drip system going to in steps. So that's 9 formations until it it's the dress that it is now. It grows with me. So also like the spider dress, there's some new technology, and I find something new, and it's like, oh cool, I put that to my spider dress, and my next spider dress is pink, and it takes over the world, right? So yeah, you never, So that's also the cool thing about like creating these things, and that's also if you look at fashion, for example, fashion is like in and out, and it's half a year, and you cannot wear that sort of, and if you look at these things and these wearables that I'm creating, and much of the community, they grow with you, they get updates and upgrades, like robotics, for example, and that's that makes it just such an different conversation. And I think all these conversations around it is something that brands are really interested in. What is the new generation of our clothing or our robotics or like these things, and the brands that I work with are really keen on finding out, and they just give me stuff, and I work with that sort of,
Neat.
So speaking of this, like continuing and adapting your designs, also collaborations, also like the social interface between like your work and human beings, right? So you took your smoke dress and updated it to be a prosthetic for the artist Victoria Modesta, is that right?
Oh, correct, yeah.
And that's like even more intimate than like, it's like a more intimate connection than even just like wearing a dress, is like having it be a part of your sort of, the way that you interact with everything. Victoria Modesta, she's an bionic pop artist. She's an amputee below the knee, and we've been working together for the last 2 years. And one thing is a photo shoot that I did with her, in where she's basically stepping on this prosthetic, and the smoke comes out of this leg, Wow. And working with Victoria is really cool, because I always need to find ways to store my electronics. It's a little backpack, or you see where this is going. So with basically her missing leg, we are working on this notion of like, it's cool to miss like a leg, because what other things can you do with that, and that opens up. For example, So for me, and the connectivity between me and Victoria is just so valuable in many ways. Like she's such a great like role model, especially for the disability community, to making it cool instead of something that is restraining you from something. It's like, no, I'm totally cool. I'm this cyborg person, and I have these even more extravagant powers to something that might be seen as missing, sort of, with her, I'm also working on a series called Sonifica. So we're using her prosthetic with an accelerometer, for example, to steer music. And she also has this tusk design, so tusks coming out of her chest almost. It's 3D printed design, and she's playing it. So we're doing a lot of interesting things with her regarding to like also the like, for example, sounds, and making these objects that she can play, but also using her prosthetic then, of course. Super cool.
A lot of people disregard technology and science as this kind of cold thing that means, gadgets and stuff, but it's like, I think that it becomes really beautiful when you mix it with human kind of meaning and purpose, and you really, kind of gel with it for a reason.
People are probably amazed by the videos and discussions. Where can they get more information about what you're doing, and maybe how they can build their own kitty ears?
Yeah, sure. Well, you can find me on Facebook, on Twitter, Instagram, such things. I am often at the bigger maker fairs, for example, being part of that, really supporting that community. I think like maker fairs and the make community is really awesome. Websites as Instructables, you can find the kitty ears. Soon the new kitty ears will be launched at Hexter. Yay! So hexter.io.
I'm so excited.
That's cool. So me and Alex, actually, we're going to make like a tutorial, so we're going to also film it for you. Also how to make it. And so I have mostly big online presence, and through the maker community you can find me. If I'm traveling to cities, like the bigger cities or wherever, I always try to find a maker space to give a workshop, give a lecture. That's all mostly for free, or like for just compensation of materials, because I'm really trying to I always say like you can make cool stuff, but also like how to trickle that down to be also having an educative notion. So I always try to do where I can to give workshops and do it yourselves and such things. So.
That's so awesome. I know, giving back to your community, and of course being an inspiration to every maker who's seen their videos. Yeah. Thank you so much for coming by Adafruit.
Thank you.
Alex, for listening as well.
Thank you for being awesome.
All right, so this was another episode of Women in Hardware. Thank you for everybody for watching. We've got even more awesome episodes with amazing women doing cool stuff with technology. Thank you for watching.
Cheers. Live long and prosper.
Ah, yeah.
Cool.